Welcome to my YouTube channel. My name is Muhammad Ubaid and this is another video on basics of structural analysis series. And today in this series we will continue with the static indeterminacy, and today we will learn how to find static indeterminacy of framed structure in 2D, and we will take an example of 3D structure also. So if you like this video, please subscribe to my channel and share this video. If you have any confusion regarding the question which we solve in this video, please comment down in the comment box and I will try to answer all your comment as soon as possible. So let's get started with the video. So we will start with a very simple example, and the example question is like this. This is fixed support and the structure is something like this. Okay, all these joints, this joint, this joint and this joint, all these joints are rigid joint and these two supports are fixed support. Okay, and we are considering this frame as a rigid frame as a 2D structure. Now what was our formula for finding degree of static indeterminacy? The formula was AM plus R minus BJ plus gamma. Okay, and now in a rigid structure, what is the value of A? A is 3 because in every member there may be axial force, there may be moment and there may be bending moment and there may be shear force. Okay, that's why the number of action available is 3. Now what is the value of B? So B is the number of equilibrium equations available at each joint. So in 2D structure, the number of available equations at each joint is 3. And what are these equations? These equations are sigma fx is equal to 0, sigma fy is equal to 0 and sigma mz is equal to 0. Okay, so this is why the number of equilibrium equations available at each joint is 3. Now let us come to our problem. Okay, so here is the problem. In this problem, how many number of member are there? So the number of member is 1 2 3 4. The number of member is 4. Okay, and the next thing is number of reactions, independent reactions. So the number of R, what is the number of R? Now let us count. There are 2 fixed support. Okay, so at each fixed support there will be 3 reactions, one in vertical direction, one in horizontal direction and the other is movement. Okay, and this will also be there. Okay, so one horizontal, one vertical and the other one is movement. So the number of reaction is 3 plus 3, it comes out to be 6. The number of reaction is 6. Now what is the remaining thing? That is number of joints. Okay, the number of joint is 1 1 2 3 4 5. The number of joint is 5. Okay, and in this case there is no release. Okay, so the value of gamma will be 0. Now if we put this in our equation, A is 3 into 4 plus number of reaction is 6 minus B is 3 and what is the number of joint? Number of joint is 5. Okay, we have counted it earlier. Now we can just calculate 12 plus 6 minus 15 and it comes out to be 18. So the degree of static indeterminacy comes out to be 3. Okay, now this is a total degree of static indeterminacy. If we want to find out the degree of external indeterminacy, we can just use the basic formula. And what was the basic formula? ds is equal to dsi plus dse. Okay, and what is the value of dse? So in 2D structure dse is equal to r minus 3. What was the value of r? 3 plus 3 6, 6 minus 3, this is 3. Okay, so after putting dse in this formula we can count ds. Okay, let us not write it again. So the value of ds was 3 and dsi we want to count and dse is 3. So from here the value of dse comes out to be 0. Okay, so we can say that the structure is externally indeterminate but the structure is internally determinate structure. So this was our first example and it was very simple example. Now we will move on to our next example. We will take a very simple example. This is a fixed joint and here the other joint is also fixed, and at this point there is a roller support, and here there is another member connected at this point, and at this point there is a hinge. Okay, what is this? This is internal hinge. Okay, this is internal hinge. Now if you want to find out the degree of static indeterminacy of this frame, okay, and this is a 2D case. Okay, it is also 2D case. So we will find out the number of member. What is the number of member? 1 2 3 4 5. Number of member is 5. Okay, because there is a hinge, so we will count these two members separately. Okay, 1 2 3 4 and 5. And what is the number of reaction? Number of reaction is 3 at this fixed joint, one horizontal, one vertical, and other reaction is moment. Okay, 3 at this joint, 3 at this joint, so we can write just very easily 3 at this joint reaction, and 3 at this joint support, and 3 at this support, and 1 vertical reaction at this roller support. So how many reactions? 3 3 6 9 10. The number of reaction is 10. What is the number of joint? We can count very easily. 1 2 3 4 5 6. Number of joint is 6. Okay, we will count internal hinge as joint. Now what is the number of gamma? As we have learnt earlier that if a internal hinge is there, then the number of internal release is m minus 1. What is the m? M is the number of member meeting at internal hinge. So there two members are meeting, so 2 minus 1, this value will be 1. Now we will just put all these value in our basic formula. What was the formula? Am plus r minus Bj plus gamma. Okay, we know that we have seen earlier that the value of A is 3 and B is also 3. So we will just put all these values. 3 into 5 plus what is the value of r? R is 10 minus what is the value of B? B is 3. Okay, and what is the value of J? 6 plus 1. So let us just count all these things. 5 15 10 and minus 18 minus 1. Okay, so 25 minus 19, this comes out to be 6. So the degree of static indeterminacy of this frame is 6. Okay, now we will just take, so the degree of static indeterminacy of this frame is 6. Now we will just take another example so that we can understand how we find the degree of static indeterminacy for rigid structure very clearly. Okay, now let us take another very simple example. So this is a, okay, let us erase this. So this is a rigid structure again, and here there is a fixed support. Okay, and here the support is pinned support. Now you can see that this is some type of other structure because there is a cantilever portion here. Now what are the number of member? The number of member is 1 2 3. Okay, very easy. And what is the number of reaction? Okay, what is the number of reaction? Number of reaction is 3 at this fixed support, one vertical, one horizontal, and movement, and at this point, at this support only 2 reaction will be there. 3 plus 2 is equal to 5. And what is the number of joints? So here is a trick. This will be a joint, this will be a joint, and this will also be a joint, and at this cantilever, and this cantilever end will also be counted in the number of joint. So total number of joint 1 2 3 4. Total number of joint is 4. Okay, now what is the number of release? The number of release is 0 because there is no internal hinge, there is no guided roller. Okay, so we will just put gamma as 0. So the degree of static indeterminacy is 3. This is also a 2D rigid frame. So 3 into number of member 3 plus number of reaction 5 minus B is 3 and J is 4 plus 0. Okay, so 9 plus 5 minus 12, this comes out to be, so ds comes out to be 2. Okay, so in this way we can count very easily what is the value of degree of static indeterminacy of any type of rigid structure. Okay, Now we will just move on to our next example. Now let us try to solve this example. So what is the number of member in this example? 1, 2, 3, 4, 5, 6, 7, 8. Number of member is 8. What is the number of reaction? 2 at this pin support and 1 at this roller support. So the number of reaction will be 3. What is the number of joint? 1, 2, 3, 4, 5, 6, 7, 8. Number of joint is 8. What is the number of gamma? Gamma is 0. So the degree of static indeterminacy will be 3 into 8 plus 3 minus b is 3 and j is 8 and 0. 24 plus 3 minus 24. This will come out to be 0. So the degree of static indeterminacy for this particular rigid frame structure in 2D is 3. Now we will move on to our next example. So let us try to solve this example, and in this example what is the number of member? Number of member is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Number of member is 11. What is the number of reaction? Number of reaction will be 1 at this roller support, 2 at this pin support, 1 at this roller support. Number of reaction will be 4. What is the number of joint? Number of joint will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Number of joint will be 11. What is the number of releases? So at this internal hinge, number of member meeting as at this internal hinge is 2. So the release will be m minus 1, which will be equal to 1. And also at these two internal hinge, the number of member meeting at each hinge is 2. So the number of release will be m minus 1, which will be 1 plus 1 for each internal hinge. So the gamma will be 3. So now we will just put the value in the formula and we will just see what will be the answer. So 3 into 11 plus 4 minus b into number of joint. Number of joint is 11 plus 3. Okay, so 33 plus 4 minus again 33 minus 3, and this will come out to be 1. So the degree of static indeterminacy for this particular rigid 2D structure is 2. Okay, now we will just take another example so that our concept may clear very well. Okay, now let us take a very simple example. Let us take a very simple example and it will illustrate very important concept. So let us see that this is a guided roller and there is a vertical guided roller and it is a horizontal guided roller, and similarly in this direction there is also the symmetry is preserved, and this is also a guided roller. And what is the support condition? There is fixed support and there is pin support and the other support is also fixed. So in this structure, what is the number of member? Number of member is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Number of member is 14. Number of reaction is 3 at this fixed support, 2 at this pin support and 3 at this fixed support. So 3 plus 3 6 and 2 8. Okay, and what is the number of joint? Okay, this is important. We are considering this all these guided roller as release. Okay, so we will just count the releases at these internal hinge, and at each hinge will be counted as a each guided roller will be counted as a joint. Okay, so we will just count the number of joint: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number of joint is 13. Okay, number of joint is, let me write it again, number of joint is 13. Number of, what is the number of releases? So this is a guided roller which will release vertical force. Okay, so there will be no vertical force, it will release, and this will also release vertical force, but these two rollers will release, these two guide roller will release horizontal force. Okay, so at this guide roller there will be no vertical force, it means there will be no shear force, and in these guided roller there will be no axial force. So how many number of releases are there? 1, 2, 3, 4. So the number of releases is, sorry, this is gamma, the number of releases is 4. So we can count ds is very easily 3 into number of member plus number of releases, and minus b is 3, j is 13 plus 4. Okay, so 42 plus 8 minus 39 and minus 4, this comes out to be 50 minus, and this will be 43, and this will come out to be 7. So the degree of static indeterminacy for this particular structure is 7. Now we will take another example of a structure having a roller, okay, in the middle of this structure. Okay, let us just draw the figure. So this is there is a roller, okay, and this is a member, this is another member which is just going like this, and here there is another roller, and at this point there is a pin support, okay, and this end is also pin supported. Now how we will find the degree of static indeterminacy for this structure? We will just count the number of member, and the number of member is 1, 2, 3, 4, 5. Number of member is 5. What is the number of reaction? Number of reaction is 2 at this pin support, 1 vertical reaction, 1 horizontal reaction, and 1 at this pin support, and 1 at this roller support, and 2 at this pin support. But because this roller support is in between the structure, so we will just assume this roller support as a release. Okay, so we will just take this roller support as release, and we will just count the number of releases for this roller support. Okay, so the number of reaction is 2, 3, 4, and 5. Number of reaction is 5. Okay, now what is the number of joints? It is very important to understand what is the number of joint in this structure. 1, 2, 3, 4. This whole assembly will count it as a single joint. Okay, 1, 2, 3, 4, 5, 6. Number of joint is 6. And what is the number of release? So this is a roller. Okay, in roller there will not be any horizontal reaction because this roller can move in horizontal direction, and also this roller cannot transfer any moment. Okay, so the number of releases will be 2. 1 is force, okay, and 1 is moment. Okay, so the 2 releases, how it is, one is let us write like this, fx, and the other is moment. Okay, so this roller support, not support, this is a roller, and we are assuming it as a release. This will release 2, okay, two reactions. One is horizontal reaction and other one is moment. Okay, so we will just use our formula, and 3 into number of member is 5, reaction is also 5, minus b is 3 into 6 plus 2. Okay, we can just count it, 15 plus 5 minus 18 minus 2, and this will be 20 minus 20. So the degree of static indeterminacy comes out to be 0 for this structure. Okay, I hope it is very clear how we use and how we solve the problems having internal hinge, internal guide roller, and the internal guide roller and the roller support. Okay, considering as a release. Now we will just take a very simple example of a 3D structure, because I want to illustrate a very simple concept. So let us take this example to understand how we will work out a problem in 3D. So this is a very simple example, and this is a 3D frame. So in 3D, at fixed support the number of reaction is 6. We know how it will be 6 because we have learned this from in our previous video. So we will just write as 6 plus 6, this will be 12. And what is the number of member? Number of member is 1, 2, 3, 4. Number of member is 4. What is the number of joint? Number of joint will be 1, 2, 3, 4, 5. Number of joint is 5. Now the important thing is about number of releases. So for a 2D structure, we will just count the number of releases by this formula m minus 1. Okay, but in 3D the internal hinge will release moment in all 3 direction. Okay, so it will be 3 times of m minus 1. M is 2 and minus 1, so it will be 3, and the degree of static indeterminacy will be am plus r minus bj plus gamma. So in 3D the number of action in a member will be 6, and what will be those action? Those action will be axial force and bending moment. Okay, let us write first shear force in y direction and shear force in z direction. Okay, axial force will be in x direction, and there will be moment mxy and myz and mzx. So this will be 6, and b will also be 6 because there will be 6 equilibrium equations, 3 for moment and 3 for forces. So this will also be 6. Okay, now we will just put all these values in this formula so that we can find the degree of static indeterminacy. So a is 6, number of member is 4, and number of reaction is 12, and the number of b is also 6, number of joint is 5, plus gamma will be, gamma is 3, we have counted earlier. Okay, 6 4s are 24 plus 12 minus 30 plus, okay, sorry, it will be also minus. Okay, so this will be equal to 6 minus 30 minus 3, and it will come out to be 3. So the degree of static indeterminacy for this frame will be 3. Now I hope that all the concepts are very clear to you. If you have any problem solving this question, you can comment down in the comment box, and I will try to answer all your comment as soon as possible. So this is it for this video, and we will meet in our next video.